Okay, now let's talk about the first real assignment for this class. All the things you guys did before wasn't graded, but this is the first assignment that will be graded. I'm going to give you plenty of time, and as you can see here, whatever you have to do isn't that complicated, but it is very true to the daily life of data scientist or machine learning engineer, where you are going to be training a neural network and you are going to be experimenting with different different variables, parameters, hyperparameters, and you'll be making a report of how these things impact. And just to make it exciting, I'm giving you 200,000 neurons. So your number of trainable variables in your multi-layer perceptron has to be at most 200,000. You can definitely use less, but you cannot use more than this. In the next slide, I'll show you how you can find the number of trainable parameters. So, few things. One, it has to be a multi-layer perceptron. You have to use the MNIST dataset. You can definitely play with other datasets, but MNIST is small enough that you can actually run it on your CPU. But I have already shown how to use GPU with Colab, so it'll make it much faster. If you use GPU in Colab, training will probably be 1 or 2 minutes. If you use your CPU, probably be 4 to 5 minutes, depending on what kind of CPU you have. Second, you want to use at most 200,000 parameters. Now you can decide how many layers you want it to be, right? These 200,000 parameters could be distributed in 20 layers, or it could be distributed in 5 layers. And as you'll see that the more layers you have, the more time it takes, but I will leave that up to you, right? Second, you can use any activation function that you want, right? I said ReLU is the choice to go, but definitely experiment with sigmoid and tanads. And I want you to document this. I want you to have a table where you have different activation functions as different inputs, and then show me what kind of results you got. Please experiment with different learning rates. These are the other variables that I want to see the results with, and different optimizers. Like I said, with Keras, you can do keras.optimizers.adam.szd. In that way, you can find all different optimizers. Third, again, I want the thing you have to submit is also your results. I definitely want to see your code in Jupyter Notebook or in Colab link, but I also want to see results. It can be part of a notebook in the form of table, or it could be in a spreadsheet, or it could just be in a Google Docs or a CSV file. But I want to see a table with all these different parameters and how these parameters impact these 4 different variables. So the loss function has to be fixed. It has to be cross entropy, because MNIST is a data set with 10 different digits. So this is a classification problem, and for classification problem, cross entropy is almost always a choice of loss function. So stick with cross entropy, but I want you to report 4 different values. That is training accuracy, validation accuracy, training loss, and validation loss. And so you want to report these 4 variables for all these different combinations. That is different type of activation functions, different learning rates, different optimizers. Now, of course, I'm not telling exactly how many rows, how many numbers to report. As long as you check all these boxes, that is, you have all these 4 values for at least two activations, at least few learning rates, at least two optimizers, that would be more than enough. And again, this is sufficient to get full credit in the assignment. However, for one person who gets the highest validation accuracy, I'm going to give a little bit of extra credit. And don't sweat too much, because the extra is not a big deal. However, if the only way to really understand how these things work is to play with different variables, and then when you play with different variables, you're definitely going to get different set of results, and I'm hoping one of these choices will lead to the result that is superior than your batchmates. Now let's see how in Keras how we can find out the number of trainable variables, right? So if you use the function model.summary, you will it'll print this table, and you can this will show you all the different layers, and it'll show you the output shapes, and you can also tell you parameters in each of the layer. But in the end, it'll also tell you total number of trainable parameters. Sometimes you might have non-trainable parameters. We will talk about those in the future classes, but for now I think if you only have dense layers and things like that, your total parameters will be same as the trainable parameters. So in this case, here you can see this is 669,000, but in your case this will not be more than 200,000. Okay. just a reminder again, now that soft deadline is July 26th. And I know this lecture already got delayed by a few days, so I can consider pushing the July 26th to maybe 29 July, if that helps you. But if you submit by July 26th, you are eligible for full credit. But again, if you're not able to submit July 26th, I will allow you to submit until August 9th. And again, this is anywhere on earth, so as long as it is August 9th anywhere on the earth, that time hasn't passed. And if you submit by August 9th, you can get up to 70% of the credit. What I want you to submit is your notebook file, IPNYB file, or just send me a Colab link. So you can just paste the Colab link in the assignments link, which I will upload on the Canvas. And if it is a notebook or a Colab, I should be able to run it. That is, there should, of course, you should have the results and all the tables, everything. But if I go to the top and say run all, it should run. And again, if you already know pandas, you can show your results, everything in that notebook. But otherwise, just have a spreadsheet where you have all these things. And just a cautionary note, because it's easy to use convolutional neural networks, which we haven't learned yet, which we will do next week, or meta learning. But please avoid those, because they will be we will learn about them in the future class. For now, I really want you guys to understand multi-layer perceptron and the various parameters that could impact the accuracy of multi-layer perceptron on MNIST. So if you have any questions on the assignment, come to the class on the coming Tuesday. After the lecture, I will stay longer and I will answer your queries. If you have seen the textbook, or you can just go to Keras website, and you can get a gist of how to make layer, how to get the optimizers, how to do the how to fix the learning rate, how to get the data set. If you Google Keras MNIST, probably you'll find how to run and how to pull the data set. And remember, this assignment is nothing. You will be able to find all of this, the whole code also on the internet. But and therefore it is very easy to simply take the existing code and play with it. However, I would encourage you to try to write as much as it possible on your own by exploring the Google Docs. And intentionally, I'm not giving you the actual Keras functions, because the process of exploring the Keras docs will expose you to all the other stuff that Keras has, and being able to Google and search things in the Keras will also take you much further. So however, if you feel you are stuck somewhere, you don't know what is going on, you have no idea where to start, feel free to ping me either on Slack or via email, and I'm happy to sit and show you in more detail. But there's nothing in this that you shouldn't be able to find from Google, and therefore if you're stuck, feel free to Google how to load MNIST in Keras. Actually, MNIST dataset is already there as a part of Keras library. You just need to find out what function. If you Google, you'll be able to know. So go ahead, get started, play with it, but please submit something by July 26th if you want full credit. Okay, hopefully see you guys in the upcoming classes.